Hello learners, welcome to Learn and Grow. The topic is about optimal binary search tree. Before discussing about optimal binary search tree, let us once recall the basic concepts of binary search tree. We all know that a binary search tree is a binary tree where every node in the left subtree is less than the root and every node in the right subtree is of a value greater than the root. Next comes the term external nodes. External nodes are those nodes where your search of a particular element stops when it is an unsuccessful search. These are the external nodes and the values less than 30 comes under this until minus infinity. And the values greater than 90 lies here up to infinity. A binary search tree that has external nodes are called extended binary search tree. With the given keys 30, 60 and 90, using this formula we can construct 5 binary search trees. These are the 5 different binary search trees for the given 3 keys. Here the cost of searching a key is different where it depends on the maximum comparisons. Here in this binary search tree the maximum comparison required is 3 and here 3. This binary search tree also takes 3 comparisons, whereas it comes to this binary search tree, it requires only 2 comparisons. So, the binary search tree which has minimum number of comparisons gives us best result. So, we prefer that binary search tree. We require a binary search tree which requires less number of comparisons for searching a key. Now, next I will show what does it mean by probability, that is successful search or unsuccessful search probability. Now next I will show you what does it mean by probability, that is successful search or unsuccessful search probabilities. I will discuss about this. For explaining this, let's consider the same example with the probabilities of successful and failures. Here, P1, P2 and P3 are the probabilities of success, where the values are given as 0.2, 0.1 and 0.1. Q0, Q1, Q2 and Q3 are the probabilities of failure, where the values of or the probabilities of the failure are given as 0.3, 0.1, 0.1 and 0.1. Binary search tree, we need to do the summation of probability of success into level of the node plus summation of probability of failure into level of the node minus 1 before one level itself. And for finding the successful search summation, we'll take I value from 1 to n. And for finding the unsuccessful search summation, we'll take I value from 0 to n. For the given example, the total cost comes into probability of success of first node, that is 30. The level of the 30 is 2. So, probability into level plus summation of 60, node 60, 0.1 into 1, and finally it gives the result as 1.1, 1.9. Move to the next step. What is meant by optimal binary search tree? If the key and their probabilities are given, we have to generate the binary search tree that the cost is minimum for finding this. Solving the optimal binary search tree, there is an issue of overlapping subproblems and optical substructure. That is why the method dynamic programming is the best way to solve the optimal binary search tree. When the value of I equal to j, then the weight of the given keys is equal to probability of its failure. By this we can by this we get the weights of these as 2, 3, 1, 1 and 1 same as the probabilities of failure, as here value of I is equal to the value of j. As the value of I and j are equal, so the cost and root are all zeros. Now let's find the cost of 0 comma 1 using the formula. Minimum of I value is 0 and k less than or equal to 1. Here the k value is 1. C of I 0 comma k value 1. 1 minus 1 0 plus C of cost of 0 1 comma j value 1. J value is 1. We are doing for this, so j value is 1 plus weight of 0 comma 1. Weight of 0 comma 1. By using the formula we get P1 plus Q1. The value of Q0 is 2 plus 3 plus 3, which results as 8. So we got the value of weight of 0 comma 1. Now let's find out the cost of the 0 comma 1. Now by substituting the values we get cost of 0 comma 0 is 0 plus cost of 1 comma 1 is 0, and we got the weight of 0 comma 1 is 8. The minimum of this is 8. So the cost of 0 comma 1 is given as 8 and the weight is given as 8. The root is taken as the minimum k value. The minimum k value is 1. So the root of 0 comma 1 is 1. By the same method we find out the all values of this and fill the table. By using the same method we have find out the all the values of the given table and we have got the values as follows. We got the cost of 0 comma 4 as 32. Now by dividing it with its weight we get 2, which is the k value. Now to find the structure of the optimal binary search tree, we have taken the cost of the binary search tree 0 comma 4 where the value got 2 and the index value of that key is 40. We have divided from there, we have taken the 40 as the root value and drawn the optimal binary search tree in this way, and this is the final structure of the optimal binary search tree. This is the algorithm for finding out the optimal binary search tree. Firstly, we are taking the optimal binary search tree function where it takes two parameters called keys and frequencies, and we create 2D arrays of with names cost and root. Here we are running a loop from I equal to 0 to n minus 1. If the I values are same, then their frequency equal to its cost. Now let's take I equal to 0, then L another loop which is L running from 2 to n. Now for calculating the j value, here we are using a formula j equal to I plus L minus 1. I equal to 0 plus 2. 0 plus 2 minus 1, which equal to 1. Now j value is 1. Now we are going to find out the cost of I comma j. I is 0 and j is 1. Firstly, initialize with infinity. For I equal to or equal to I to j, we are going to run a loop, and using this formula we are going to find out the cost of the given I comma j. For the values 0 comma 1 we get the cost as 8. C is less than infinity where we have initialized it with infinity. The C value is less than cost of I comma j. So We change it to C of cost of 0 comma 1 to 8 and root of 0 comma 1 to 1. We'll repeat this until n value and we'll get the values of and we'll get the cost of 1 comma n. From this we'll get an minimum total cost of a binary search tree. This is the algorithm for optimal binary search tree. So this is the approach of dynamic programming, and we have solved one of the problem using dynamic programming now. So that's all in this video.